two power series. Determine the interval of convergence and radius of convergence. So the first one, I would like to use the ratio test. And then the an is equals to x to the n divided by n factorial. And then the next term, an plus 1, is equals to x to the n plus 1 divided by n plus 1 factorial. Factorial has a lot of fun. So this is x to the n times x to the first, and then the factorial, we start with n plus 1, and then the next term is n factorial, because the next term is always 1 less than the previous term, right? So we have a bunch of products. The next term is always 1 less than the previous term. So the decrement is equal to 1. That's how the factorial works. And then we set up a ratio, n approaches to infinity, and then an plus 1 divided by an. So that is equals to limit as n approaches to infinity. We have the next term times x divided by n plus 1, and then n factorial divided by the reciprocal, which is multiply the reciprocal, n factorial, x to the n, and then we do a cancellation, should be easy, x to the n, x to the n, n factorial, the factorial needs to be cancelled, otherwise you will make a huge mistake. Alright, what do we have left? We have limit as n approaches to infinity. We have 1, right? So we have 1 divided by n plus 1, and then times x. How do we get rid of that? So you don't really need to do anything. When n approaches to infinity, you have a 1 divided by infinity, right? So you have a 1 divided by infinity, and then multiply the absolute value of x, which is 0, times the absolute value of x. I have to let you know that yes, you are right. You are very happy. This is just equals to 0. Okay. And then now, can this be less than 1? Can this be less than 1? Yes, right? So that is less than 1. And what else? For any x. So that's why I picked this problem. You solve the whole thing, you complete the series, and then at the end of the day, you have a 0. You still do a less than 1. Now, let me explain why we still do less than 1, although we already explained that twice in the previous video. Look at the x raised to the n. So x raised to the n, does that remind you anything? That reminds you the geometric series. And then for a geometric series, we have a common ratio raised to the n power, right? In order for the geometric series to be convergent, the absolute value of the common ratio must be less than 1. So that's why we must say that it's less than 1. So since 0 is always less than 1 for any x, and then what do we say? We say that the series is always convergent for any x. So we say the series is always converge for any x. How about the interval? So for the interval, we have a straight line. This straight line stands for all the x value, and then there is no interval. So we have 0 in the middle. We say always converge. So that means it doesn't matter what x value you pick, that is always converge. So the interval of convergence is from negative infinity to positive infinity. So we can determine the radius then, because there is the interval is huge, is infinitely is huge, right? We cannot decide any radius. So that's it. So that is the end of number 3. So in number 4, you expect to see something other than 0 less than 1, and that's why I picked that problem. Okay, I don't pick random problem to discuss. I picked that problem to discuss because that is a good problem for discussion. Okay, next one, I remember I use yellow. So next one, we have the summation n equals to 1 to infinity, x to the n divided by n to the 4 times n to the 4 times 4 to the nth power. This one, again, I will use a ratio test. The an is the given power series, and then the an plus 1, that is equals to x to the n plus 1 divided by n plus 1 to the 4th power, and then 4n plus 1. So that is x to the n times x divided by n plus 1 to the 4th, and then 4 raised to the n times 4 raised to the 1st. and then we do limit as n approaches to infinity. We have an plus 1 divided by an, that is equals to limit as n approaches to infinity. We have x raised to the n times x divided by n plus 1 raised to the fourth power times 4 raised to the n, and then 4 raised to the first, and then you multiply the reciprocal of an, that is n raised to the fourth, and then 4 raised to the n divided by x to the n, and then let's do some cancellation. So x to the n, 4 to the n, 4 to the n, and then I believe that's it. So let's pick the leftover. So we have limit as n approaches to infinity. We have x. No, let's take care of the n. So we have n to the fourth. I got an idea. So n to the fourth divided by n plus 1 to the fourth. I just keep that in like this. So we have this, right? So that's the leftover. Now, oh, no. Missed something. Missed the 4. X divided by 4. Now, the n, we don't need n. We don't need the x. We don't need the absolute value anymore, right? So that is limit as n approaches to infinity. I will just do this. The entire thing raised to the fourth, n divided by n plus 1. And then we have absolute value, x divided by 4. Oh, the 4 is always positive, so we don't need an absolute value for that. Absolute value reserved for x. And then the 4, we don't need an absolute value. So how do we take care of the fraction? The highest degree is 1, so we divide each term by n raised to the first power. And then the next step, we have limit as n approaches to infinity. We have 1, right? 1 plus 1 over n raised to the fourth, and then absolute value of x divided by 4. So as n approaches to infinity, you only have a 1 in the big parentheses, so you only have the absolute value of 4. And then what do we have to say? Take a look at the yellow highlight. That must be less than 1, right? It's because of the geometric series. So in the given series, we have x raised to the n. That is a geometric series. The common ratio, which is the base x, must be less than 1. The absolute value of x must be less than 1. This idea came from the geometric series. All right, so less than 1 to make the series converge. You can write this down on your notes, so when you go back to read your notes, you know why we have to do this. And then we solve this inequality. First, we multiply both sides by 4, and then we have the absolute value of x less than 4. So that is negative 4 between x and then between 4. We have to test the negative 4. We have to test the 4. I like positive, then let's test the positive first. So when x is equals to 4, you plug in 4 to the power series. You have 4 raised to the n divided by n raised to the fourth, and then 4 raised to the n. So the 4 raised to the n got cancelled. Then we have n equals to 1, 1 divided by n to the fourth, right? So this is a p series. And then the power is equals to 4 greater than 1 according to the p series. When the power is greater than 1, then the series is converged. So when x is equals to 4, we have a converge. What about when x is equals to negative 4? Then you plug in a negative 4. Then you have negative 4 raised to the n divided by n to the fourth times 4 to the n. And then the negative 4, you can break this down into the negative 4. I should do this in another color, in red. The negative 4 raised to the n is equals to negative 1 times 4 raised to the n. That is negative 1 raised to the n times 4 raised to the n. All right? And then you can do negative 1 raised to the n times 4 raised to the n divided by that. So now you see that why they put a 4 in there, right? So these two got cancelled. And then we have an alternating series. Then we have to test those two conditions. And then you have to test the Bn, which is 1 divided by n to the fourth, and then Bn plus 1, 1 divided by n plus 1 to the fourth. And then you have to show that Bn plus 1 is less than or equal to Bn. So when n is equals to 1, we have 1 divided by 2 to the fourth. That is definitely less than 1 raised to the fourth. And then number 2, you have to show that as n approaches to infinity, Bn is equals to 0. So you have limit as n approaches to infinity, 1 divided by n to the fourth, that is sure equals to 0. So that means you have a converge as well, because according to the alternating series test, number 1 is satisfied, number 2 is satisfied. So overall, the series converge. So we have a converge and a converge. So how do we draw the conclusion, the number line, interval of convergence? So this entire line represents x. We have a negative 1, negative 1. No, not negative 1, negative 4 and 4. And then they are both converged, right? So that means you can put a solid circle right here and a solid circle right here. And then the middle is equals to 0. So that means between negative 4 and 4, including those two endpoints, we have a converge. Outside of this interval, we have a diverge, and then we have a diverge. Okay, so the interval of convergence, you can write negative 4 to 4 in square bracket, or you write negative 4 less than or equal to x less than or equal to 4. So the idea is, before you test each endpoint, you are in this status, right? Before you test the endpoint, you are in this status. There is no way to put the negative in there. Sorry, there is no way to put the equal in there, because that what you did before this line, that doesn't guarantee that the power series is convergent at those two endpoints. So since that doesn't guarantee, then you have to do extra work to test that is converged or not. So that is the extra work. And then after doing the extra work, we know that they are both diverged. So now we can put an equal for each inequality. And then what about the radius? The radius, so half of that. So the radius of convergence is equals to 4, right? That is, there is a 4 unit between the 0 and the 4. All right, so that is the end of this video. What do you think? Did I help you? Did I give you a good explanation? Let me know in the comment section below. Like the video, share the video for me, subscribe to my channel. I really need some like for the videos, all right? I appreciate your help. I see you all in the next lesson. In the next lesson, we will do more power series. I see you there.